Yeah, of course. Cordelia, for now in Bangkok, thank you very much. Well, for more on how this could have happened and how common air pockets are, I'm joined by Professor of Atmospheric Science, Paul Williams. Good to have you on the programme, Paul. For passengers, utterly terrifying. Let's start by just explaining what turbulence actually is.
Well, very simply, turbulence is just strong currents of air that impact against the plane and push it around. And mainly we're talking about up and down motion. So it's motion in the vertical direction. And there are different ways in which turbulence can be generated, actually. So storms can do it, where nobody likes flying through a storm, but also flying over a particularly high mountain, because the air blowing over the mountain can break down into turbulence. And there's a third kind as well, which is strong air currents in the jet streams can cause a kind of turbulence called clear air turbulence, which is in fact invisible.
So that kind of turbulence, even the pilot isn't aware that it's coming up.
Not even the radar in the flight deck can see this kind of turbulence. It comes literally out of the blue, in fact, when passengers can be walking around inside the cabin, the seatbelt sign switched off, and it can be particularly hazardous precisely for that reason.
So you think it's that type of turbulence which probably caused this tragedy?
I don't know. We will obviously be looking in detail at the meteorological context that led to turbulence this severe. It will take us days, weeks, months to do those analyses in detail. And at the moment, I don't know whether the encounter today was to do with a storm or a mountain range or this clear air turbulence. We'll have to have a look.
Yeah, of course. It will be poured over, won't it, the detail. I've flown that route, London to Singapore, a number of times, and it is quite common to experience turbulence, isn't it, on that journey?
Yes, I've flown it myself many times. I mean, it is important to emphasise because I'm always aware perhaps some of your viewers are heading to the airport in the next few hours, and a lot of people are nervous flyers. So turbulence is kind of rare, 0.1%, so 1/10 of 1% of the atmosphere at flight cruising levels has severe turbulence in it. And severe turbulence, by definition, is stronger than gravity. So if you're flying through severe turbulence, gravity can't pin you to your seat. So the plane can be moving down more rapidly than gravity can keep you pinned to your seat. So if you're not seatbelted, you will start to lift up. And sadly, that is what appears to have happened today. So it's quite rare in the atmosphere, but consider how many thousands of aircraft are in the skies at any time. And one of those will sadly seek out that turbulence, as has happened today.
Yeah, it's a good point to make, just saying how rare this type of turbulence is. And we've heard reports of people literally being lifted out of their seats and hitting the ceiling above them, which just must be so frightening. You did a big report, a big study, I believe, showing the effects of climate change on turbulence. Tell me about that.
Well, we've suspected for around a decade now that there ought to be a link between climate change and turbulence. Our computer models were suggesting that there could be twice or even 3 times as much severe turbulence in the coming decades because of the particular ways that climate change is changing the jet stream. And indeed, those predictions have been confirmed recently. We published a study last year which looked at observations of the atmosphere and found that today there is 55% more severe clear air turbulence over the North Atlantic than there was back in the 1970s when satellites first began observing the atmosphere. So there is a projected increase in the future, and it seems that, in fact, that increase has already begun, and it's clearly linked, as you said, to climate change.
Yeah, the irony being, of course, that aviation does help contribute to that. And just finally, what about technology? Is that helping to mitigate the effects of turbulence? The design of plane, new technology such as apps. I know even now you can get an app which will show you where turbulence may occur on the flight that you're about to board.
Well, we do have turbulence forecasts, and pilots use them every day to try and plan the smoothest route possible. They're not always, just like a weather forecast, they're not perfect, and sometimes they get it wrong. And there is technology as well that we might see rolled out in future, so that the radar on the flight deck can't see invisible clear air turbulence, but a slightly different technology called LiDAR, which uses a different kind of light, can in fact see the invisible clear air turbulence, but it's very expensive, currently. Maybe in future, as the costs come down, we'll see this technology rolled out, and it could have the potential really to confine encounters with clear air turbulence to the history bins if it's as successful as the initial experiments that I've seen, if that potential plays out in future.
Gosh, that would be incredible, wouldn't it? But for now, it's the old technology of a seatbelt, which is going to keep passengers safe on board an aircraft. Thank you very much for that, Professor Paul Williams, Professor of Atmospheric Science.